Okay, so could you introduce yourself, please?
Yeah, I'm Laura Judd. I am a research scientist at NASA Langley Research Center, and I'm here leading science measurements on the NASA G-3.
Oh, so what is G-3? Like, what is that?
So the G-3, it stands for Gulfstream 3. It is a small jet. And in that jet, we have two window portals that are in the belly of the plane. And we are doing remote sensing of air pollutants over the Bangkok area.
Okay, so you say the two hole, like two sensor, let's say that. So, so what do they do?
Right. The one in the front portal, it measures sunlight that has traveled through the atmosphere and comes back up to our telescope. It's spectrally resolved light in the ultraviolet and visible wavelengths. With that, the pollutants that we're measuring leave fingerprints within that light. And with that, we can tell how much of that pollutant is below the aircraft.
So we see the the pollution below the aircraft.
Yes.
So what is exactly the pollute, like, you know, because we have a lot of things like under the plane. So what is exactly you measure with the first sensor, right? Okay.
The two main products that we measure with that instrument, the first one is nitrogen dioxide, or NO2, as I might call it. This is an indicator of fossil fuel combustion largely. It does come from natural sources such as lightning or soil emissions, but when we see a global picture of nitrogen dioxide, we largely see where people live. We see where cars are driving, where power plants are operating, where there's industrial areas, etc.
So higher the nitrogen dioxide is bad.
Yes.
The higher the worse.
Yes. So nitrogen dioxide has been found to be associated with causing pediatric asthma. But it also probably just as importantly, if not more importantly, it contributes as an ingredient for secondary pollution, and that's pollution that's not emitted, but it's created through chemistry. So it is a necessary ingredient for PM 2.5. Those are particulates that are very small, so small that they get into our bloodstream through our lungs. And then ozone, which is also harmful to our respiratory system if we breathe that in. At high levels.
So let's say that if you come in here, you measure like our pollute and everything, so we can know where is the pollute come from, right? Is that how you can what is the questions of the research or the research?
That's the idea is to better understand where that pollution's coming from, as well as how all the different pollutants go together to create these what we call secondary pollutants, such as the particulate matter. So one of the things we can do with high resolution maps of nitrogen dioxide is be able to tell where in the city these emissions are coming from and what is the background coming in.
That's interesting. So I heard that you fly the two flight already, so I think it's a good flight, right?
Oh yeah, yes. So we flew two flights yesterday, and it was a beautiful day. When we fly, we typically look for nice sunny skies. We are measuring in the visible and the ultraviolet part of the light spectrum. If there's clouds in the way, our measurements can't see underneath, and we care about the air that we're breathing near the surface. And so yesterday we were fortunately able to capture some nice clear skies, and we're looking today to measure some more as we have some clear skies over Bangkok this morning.
Okay, so this morning you also fly, and it's your third flight.
Yes.
Okay, so why is I heard mostly you over Bangkok.
Yes.
But why you have to be a pattern like this?
Yes. So when we measure, we see just a small field of view below the plane. So that is with the front instrument that I talked about.
Yeah.
So we can see it from 28,000 feet. We have a field of view of about 7 kilometers. And so these lines are spaced in a way where we can create a gapless map over the city. And we repeat that up to 3 times in a day as we see that these pollutions change a lot throughout the day. We will also, I didn't talk about the back instrument on the plane and the back portal.
Okay.
We also have a LiDAR on board. And that LiDAR, so with the front instrument, we're getting a 2-dimensional map of how much pollution, nitrogen dioxide is below the airplane. But with the LiDAR, we can actually profile what is the vertical distribution of aerosols or particulates below the aircraft, as well as ozone profiles as well. So when I talked about creating these secondary pollutants, the LiDAR is actually profiling that along these 10 flight lines over the city.
Okay, so why Bangkok? Like, why you not move like a bit further, or you choose Bangkok because it's a capital city?
So what we found in the past, one, when we look at the satellite, Bangkok has the highest signature of nitrogen dioxide over Thailand. And then we also find that air pollution near coastal environments are very interesting, as small scale dynamics can complicate what we are, how models are creating pollution. But we chose just one city over Thailand because we want to gather the statistics. It takes some time to create these maps. The larger map we can create, the larger area that we can see, but if we can repeat that up to 3 times a day, we can see the diurnal evolution. So right now we do have the first satellite measuring these pollutants from space, launched by South Korea in 2020, called GEMS. And we're flying underneath that satellite as well, so we'll be able to work with you guys on how that satellite and those measurements fit into these higher resolution measurements, as well as the in situ measurements we're getting from the DC-8.
Yeah, that's interesting. That's how the GISTDA going to work with you, you guys, about the satellite stuff. Okay. So what do you like planning on next flight? How do you plan, like, so you still be here until like 25. So how do you gonna plan on that?
Yeah, I expect we'll probably fly another 3 or 4 days while we're here over the next week. So conditions that we're looking for are relatively clear skies. We also want to fly when our other airplane is airborne as well. So we're up high mapping over the city, and the plane is measuring numerous more species than what we can see from the airplane below us to add context to it. So that'll be important as well. So the next few days, it looks like we're having a few changes in the meteorology, measuring under different meteorological conditions, such as wind directions or where the air masses are coming from, can tell us about the variety in the area. So we're excited about that. And it looks like we have some interesting opportunities over the next 4 or 5 days.
Oh, okay. So how was it for the last like 2 flights? What is like I don't expect like the result to come right now, but what do you guys see? Like, how was it?
So we did our first successful flight yesterday over Bangkok. And from what we saw from the preliminary data, we could see some hot spots over the city from where nitrogen dioxide was higher than others. We could also see there was a decent amount of particulates or aerosols in the boundary layer, that lowest layer in the atmosphere that we live in, as well as very high ozone. So it's all preliminary data. We're really excited to dig into it, and over the next couple days we'll have kind of some quick looks to look at, but it'll take some time to process that and then work with you all to understand how these pieces all fit together and tell the story of air pollution over Thailand.
That's interesting. So we can like more understanding of what the data that we cannot understand more like of it by satellite or everything. Okay, that's interesting.